The natural causes to acidification in the ocean are acid rain and natural climate changes. The environment changes all the time and it's always been like that. Still, the oceans have sustained a relatively stable acidity level for millions of years. But the acidity levels today is way higher than ever before, and research shows that the balance and a stable level is being undone because of a rapid pH drop and the high amounts of carbon dioxide in the air. The atmospheric carbon dioxide comes primarily from human fossil fuel combustion. And since the Industrial Revolution 250 years ago, atmospheric carbon dioxide have increased with around 40%. Another name for carbon dioxide caused and created by humans are anthropogenic carbon dioxide, a word that will be used further in the text. The anthropogenic carbon dioxide added to the atmosphere is reduced by the oceanic uptake. The oceans take up around a fourth of the anthropogenic carbon, which is produced by humans. However, the ocean uptake is not favorably for the oceans. It causes pH reduction and ocean acidification. The pH in the Australian oceans has dropped by around 0.1 pH units, which is comparable with a 30% increase in acidity. And it's predicted that the pH could drop with around 0.5 pH units by 2100, depending how much anthropogenic carbon dioxide being released into the atmosphere. If we don't do anything about the carbon dioxide exhaustion, we will probably have that 0.5 pH drop at the end of the century, which can be compared with a 320% increase in acidity. So, the causes of the Australian climate changes and oceanic acidification is the high and increasing levels of atmospheric carbon dioxide, which, said before, is mostly caused by humans. That means that the answer to the first question is the human fossil fuel combustion causes and leads to low pH and acidification.
What is the consequence of acidification? There are a lot of consequences which affect different species differently. pH reduction is a big risk of destroying shells of plants and animals, which affects a lot of creatures like corals, who can start to crumble, and for some species it will be harder to reach in older age. Important metabolic processes, such as respiration in fish, may also be impaired by the acidity, as lowering the pH reduces the efficiency of oxygen exchange in the gills. But the ones who are the most affected are the microscopic plankton with its calcareous shells. The microscopic planktons is very important to our cycle because of the big production of million tons of oxygen. And if their shells are thinner or deformed, the organisms may be unable to function properly. Coral bleaching happens when the coral's embosymbionts, which is the dinoflagellate that lives inside the coral and gives the food, stops working. And that results in that they lose their photonetics pigments, and the embosymbionts give the coral its color, which is why the corals turn white when they calcify. And when the embosymbiont stops working, the corals slowly starve to death. Some of the coral reefs has already been damaged by calcification by increased temperatures, which affects corals by bleaching and reduce the growing process, which makes them extra hard to regrow after predators. El Niño in 1997 to 1998 has affected the coral reefs by mass bleaching. When it raised the water temperatures, it caused problems for the coral reefs. But the coral reefs can recover if the hot water temperatures don't hang in for too long. Around 60% of the coral reefs in the Great Barrier Reef had suffered, and some has lost around 90% of the corals in the same areas. The carbon dioxide emissions in Australia was 16.5 tons per capita in 2011. All this carbon dioxide is released into the air by one person, and Australia has approximately 23.5 million inhabitants. Everyone has their own responsibility to reduce their carbon footprint. So what could we do to prevent this acidification?
Well, at first we thought it was a good thing that the oceans absorb CO2. That would leave less greenhouse gases in the air and by that prevent the global warming. CO2 makes the biggest contribution to the global warming. But with time we understand that this, on the other hand, would lead to a negative change of the ocean's chemistry. When carbon dioxide dissolves in seawater, the water becomes more acidic, which means the pH drops. But then we have a natural buffering system that occurs in the oceans. A buffering system prevents pH changes and keeps the pH stabilized. Then we wouldn't have any problems, right? But we have, because too much CO2 is dissolved in the oceans. So the natural buffering system hasn't been able to keep up. This equilibrium you see in the picture tells us how the buffering is done. This natural buffering system is called hydrogen carbonate system. As you see, when CO2 combines with water to form carbonic acid, the bicarbonate molecule will through proteolysis release a hydrogen ion and becomes negative charged. We know from Le Chatelier's principle that if we increase the concentration of carbon dioxide, the equilibrium will move to the right, and we would have an increase in the concentration of hydrogen carbonate and hydrogen ions. This would eventually lead to lowering the pH. Another problem that comes across is that the sea surface in Australia is getting warmer with time. The sea surface temperatures around parts of Australia have been mostly well above average since 2010, which means that less CO2 would be absorbed by the oceans and more would stay in the air instead.
All of these facts leads us to one central solution. To prevent acidification in Australian oceans as well as other oceans, the CO2 emissions needs to reduce. This is both for our planet's sake, the marine animals, and necessary for maintaining an ocean full of life. So how could we accomplish that? Changes can happen both individually, locally, and globally. Spreading knowledge about ocean acidification is probably the very first step towards a healthier planet. I mean, if people are not aware of the ocean's situation, they won't even know that they need to reduce their CO2 emissions and change their habits. Lectures are one way to spread knowledge. Putting up posters, articles in local newspapers, or sending local TV shows about the acidification issue are other ways to involve people. Australia as a country could help by sponsoring and supporting research about ocean acidification. Australia is a country with lots of sunshine hours. That's something great to take advantage of when it comes to energy. Just think about how much heat and electricity the sunlight would turn into from solar panels. In addition, the CO2 emissions from power stations would reduce. According to BBC News, there was 4,500 registered solar panels across Australia in 2014. That's more than 1 of 10 houses equipped with solar panels. But the purchase price needs to minimize in order to make the majority of our inhabitants install solar panels. It's very important to take advantage of the resources that we have in Australia, in this case the sunlight. Travel less by car because any vehicle that uses fossil fuels releases much carbon dioxide. Choose public transportation alternatives instead as bus, subway or train. They are able to transport bigger amounts of people at once, which will lead to less carbon dioxide emissions than if all those people had gone by car. Another example is to avoid getting stuck in traffic by planning your trips so that they won't occur on special times of the day when there is much traffic and long queues.
The global carbon dioxide emissions from fossil fuel combustion was estimated to 35.6 billion tons in 2012. We can also see from the diagram that the carbon dioxide concentrations in Australia has increased enormously. That number needs to reduce as much as possible, and we will do what it takes to minimize our part of the global carbon dioxide emissions from fossil fuels. For example, by introducing more electric and hybrid cars into the society. Hybrid cars has a combination of two engine types. They are equipped with a fuel tank, at least one electric motor, and a battery pack. The electric cars doesn't release any carbon dioxide or other gases, since they purely run on electricity, while the hybrids use less fuel and therefore releases less CO2. It would also be good if electric and hybrid cars became more common all over the world, in order to fight against the CO2 emissions. Last but not least, emissions from airplanes actually stands for as much as 2% of the global CO2 emissions. That number will grow with time if no changes are made. Emissions from airplanes contains 8% carbon dioxide. Some kind of changes in the airplane's engines or fuels are necessary. At the same time, would it be good if people didn't fly as much as today? Alternatives that are better for our planet are today always more expensive. For example, solar panels, hybrid or electric cars, and organic food. Lowering prices would encourage people to choose these alternatives, and by that not only prevent acidification in the ocean, but also prevent global warming.
Coral reefs are under a big threat worldwide because of the CO2 emissions that humans are responsible for. We want to strive for a better and healthier coral reef in the Great Barrier Reef of Australia. And we can do that through a method called calcification. By doing this, we would not just maintain the coral reefs, we would also control the ecosystem and try to repair it, because many species are associated and dependent on the coral reefs. Coral calcification is important and necessary because it helps the coral reefs to build up their structure. It is also important to keep on monitoring the oceans and surveying the health of the corals. For over 20 years, the Great Barrier Reef has been monitored, and by doing this, we see drastic changes in the reef communities. Monitoring helps us be aware of the life under the sea. For instance, the variability of coral and fish populations, but also if the reefs are under pressure. In the future, monitoring should be more common, and the long-term damages on the oceans would disappear.
Remember this, no one can do everything, but everyone can do something.
If everyone changed something, we would make a big change together. Thanks so much for your attention.